Well students, let's move to the another example of disaccharide, that is maltose. Maltose, it is commonly called as malt sugar. And it is a principal disaccharide obtained by partial hydrolysis of starch present in malt. It is obtained by partial hydrolysis of starch present in malt. Okay, and students, on hydrolysis, 1 mole of maltose gives 2 moles of alpha D glucose. Upon hydrolysis in acidic medium, it gives 2 moles of alpha D glucose. Okay, and it is a reducing sugar. And now I am going to discuss about the structure of maltose. In case of maltose, 2 alpha D glucose units combine together to form maltose. Alpha D glucose in case of alpha, OH group is present on right hand side at anomeric carbon or at C1 carbon, and this one is a C1 carbon, this one C2, C3, C4 and C5. And in case of alpha D glucose, OH is present at downward side as it is present on right hand side. Okay, this is the structure of alpha D glucose. Okay, and another one is also, second unit is also alpha D glucose. CH2OH, 5th carbon, 4th carbon. This one is a 3rd carbon. This one is 2nd. And in case of alpha, OH is present at the right hand side, so it is placed downward. Okay. When these two units join, then the loss of water molecule take place, and again these two units join with the help of oxygen, and it is called as glycosidic linkage. And in this part is non-reducing in nature, and this one is reducing nature, as it contains free aldehyde group, so it is reducing sugar. Okay, now let's move to the another example of disaccharide, that is lactose. Lactose, it is commonly called as milk sugar. milk, sugar. Lactose occur in milk, therefore it is called as milk sugar. Okay? And lactose on hydrolysis in presence of acid give equimolar mixture of beta D glucose and beta D galactose. Upon hydrolysis, lactose in acidic medium it gives equimolar mixture of alpha D galactose and beta D galactose and beta D glucose. And these galactose and glucose are apimers of each other. What are apimers? The change in the configuration of OH at any chiral carbon atom. So they are the apimers of each other. Okay? Lactose. In case of these two units join together to form lactose. In case of beta, OH is present at left hand side, so it is placed on upper side. And in case of in case of galactose, OH is present at left hand side, also on the fourth carbon atom. So, in case of galactose, OH is placed at upper hand side. And in case of beta D glucose, again OH is present at C1 carbon on the left hand side, so it is placed at upper side. And when these two units join, then the loss of water molecule take place and these two units join through oxygen. And again it is called as glycosidic linkage, and this part is alpha D galactose. And this one is alpha D glucose. This part of lactose is non-reducing, but this one is reducing part. That's why lactose is a reducing sugar, as in this first carbon it contains free aldehydic group. I hope it is clear to all of you. Thank you, students.